All right, welcome to Unit 4, Probability, Random Variables, and Probability Distributions. This is a continuation of Topic 4.10, Introduction to Binomial Model, but this is Part 2. We are going to start to actually analyze, now that we know what the binomial distribution is all about, now that we're going to really find probabilities within the binomial model. All right, so to best understand how to calculate the probabilities in the binomial model, we need to look at an example. So the probability that an adult has type O negative blood is 7%, and a group of 10 randomly selected adults, let X be how many people have type O negative blood. Once again, we are told the probability of success is 0.07, which means the probability of failure is 0.93. We were given a set number of 10 trials. So we also know that on every single person, you either have the blood O negative or you do not. That's the first condition we got to check. Second, we know that the probability of having the blood is 7%, and that should stay the same from person to person. It's not going to go up or go down. And each person's likelihood is independent of the next. People do not affect each other when they're randomly selected. All right, so let's make a probability distribution. Now remember, a probability distribution has X, all of the outcomes. Now remember, we're looking for how many people have type O negative blood. Well, if there's 10 people, none of them can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I ran out of room. You know what? Let's make this nicer. Here is a very nice, pretty chart for all the outcomes. This is discrete because I just made a list of all the different outcomes for how many people could have O negative blood. Now I just got to find the probabilities. Let's explore 3, for example. Now, if 3 people have type O negative blood, that means I need 0.07 to the third because I need 3 people to have the blood. And that means 0.93 would be raised to the 7th because I need 3 successes, 7 failures. 3 people to have the blood, 7 people to not. Now, the problem is this, is that how many different ways can that happen? You know, I could have the first person have the blood and then no, then the next person does, no, and then the next person does, no. So there's my 10 people, 1, 2, 3, 4, 5, 6, 7, 8, 9, whoop, I forgot a person, there's another no there. And again, of those 10 people, 3 have the blood, those are my check marks, 7 do not, those are my dots. But again, that's only one possibility. Now, granted, that possibility has 3 0.07s, so 0.07 to the third, 7.93, so 0.93 to the 7th, 3 successes, 7 failures. But it could also happen like this. First person, no. Second person, no. Third person, no. Fourth, yes. Fifth, yes. Sixth, yes. 7, no. 8, no. 9, no. 10, no. So there's my 10 people. And there's my 3 successes, the check marks, and then the 7 failures, the dots. And by the way, there might be more options. So, boy, this is seeming kind of difficult. So let's kind of take this part by part. The probability part should be really, really easy. If you just think about it, for 3 successes, that means 3 people have type O negative blood, and that means 7 do not. That should be fairly simple. Like if you're struggling to understand this, you might have to go back and watch some of the other probability videos. But this makes sense. If I have 3 people that have the blood, that means 3 people had a 7% chance, and it happened. And that means the other 7 had the 93% chance, and it happened. This is multiplication, okay? Now, the problem is, like I just explained to you, how many different ways can this happen? 3 successes, 7 failures. Well, there's actually a function that can help us figure that out. All right, here is the function. This is called the binomial function. Now, I know this looks very intimidating at first, but just give me a minute to explain. So here, right here, this part right here, right there, this is the probability of success. And we want n successes. In that case, or in our specific case, that was 3. Over here, this back part, that's our failures. And we wanted 7 failures. So again, that's where we're getting 7 from. Now, this front part right here is the part that explains to us how many different combinations there are to have 3 out of 7, excuse me, 3 out of 10 successes. That's the part that's tricky to us right now. That's the part that we need the function for. So to better understand this, let's look at it through the eyes of the problem we're currently looking at. On the far left, we're trying to find the probability of 3 out of 10 successes. This is the part that shows us 3 successes, 0.07 is success to the third. This back part is the failures, 0.93 is the probability of failure to the 7th. That's the number of failures we have. And this front part is actually called combinations. Now, you might be like, what is this giant parenthesis? This is weird. Well, this is actually a mathematical notation. This is 10 choose 3. This right here represents how many different ways you could have 10 items and choose 3 of them to be successful, which implies that 7 are failures. This is actually a mathematical notation for 10 choose 3. How many different combinations of 3 successes out of 10 can you have? I could sit and try to list them: success, failure, failure, success, success, failure, 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 failure. There you go. 3 successes, 7 failures. But another combination could be failure, success, failure, success, failure, success, failure, 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 failure. Yet another combination: success, 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 failure, 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 failure. So again, I don't want to sit here and try to figure out how many different combinations there are. I want the calculator to tell me. That's where this notation comes in. The actual mathematical formula for this notation is, again, the generic, it's n choose x. So you have n factorial on top. On the bottom, you have x factorial times n minus x factorial. So if we're doing 10 choose 3, that's going to be 10 factorial on top, 3 factorial on the bottom. 10 minus 3 is 7 factorial as well. Now, if your mind is bracing right now and your mind is saying, what the heck is a factorial? That looks like an exclamation point. Well, maybe go back to pre-calc. 10 factorial mathematically is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 3 factorial is 3 times 2 times 1. So a factorial is you just keep multiplying down until you hit 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, I'm not trying to overload your brains right now. That's a lot of work. You know what? Our calculator could do it all for us. So we don't even have to do that work. We have a command on our calculator that looks like this: 10 choose 3. And this command does exactly the math here. So instead of us doing the math, we could have our calculator do it for us. Here is how you get that command. First, type in the total number of trials, 10. Type that in first. Then go and hit math, then hit probability, and then you're going to select option number 3, which is the NCR. That'll bring the NCR to the screen. After the NCR, you need the X, how many successes you want, and that's when you type in 3. So you have to type in 10, then the NCR, then 3. Now, it says NCR, but really we call that RX, the number of successes. So again, you got to type the 10 in first. That way the calculator puts those two numbers together. Then you got to type in the 3 after the NCR, and that tells the calculator what X is. And then hit enter, and you get the result. So there's 120 different combinations of 3 successes and 10 failures. So that's what the calculator is doing. That's what this function is calculating. So when we go back to the binomial function, you have to understand that if you're trying to find the probability of 3 successes, you need to figure out how many combinations there are. That's the 10 choose 3. Then you have to understand that you have 3 successes and 7 failures. Put all of that together, you get the answer. But again, let the calculator do the hard work. The hard work is figuring out how many different ways you could have 3 successes out of 10, and that's what the calculator does, and it gets 120. So now you just got to put all of that together, and you get 10 choose 3, which is equal to 120. Your calculator told you that. This is just the notation. And then you times that by 0.07 to the third, 0.93 to the seventh. Again, take a deep breath. Keep in mind, it's this whole idea that if you have 10 people, we need 3 check marks. And then we have to have 4 failures, non-check marks. You have to understand that those check marks are worth 7%, and there's 3 of them. The failures are 93%, and you have 7 of them. But the hard part is figuring out how many different ways can you have those 3 check marks. And I don't want you to have to worry about that. I want you to use the calculator that tells you 120. So then all you got to do to find the probability of 3 successes is multiply the 120 times 0.07 to the third times 0.93 to the seventh, and voila, you get the answer, 0.0248, 2.48%. Now listen, all we did was find the probability of 3 successes. We now need to find the probability of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or all 10. But listen, if you understand the process, it should now go a lot faster with our calculator. So let's walk through this. Let's find the probability of 0 successes. 10. Slide over to probability. Choose 3. I'm sorry, 0. We're trying to find the probability of 0. 0 successes. Well, there's only one way that can happen. They're all failures. That makes sense. We're going to take that one. We're going to multiply it by 0.07 to the 0. No successes. Times 0.93 raised to the 10th. All 10 failures. And voila, we get the answer, 0.4840. .4840. Now, how did I get that answer? I did 10 choose 0. 0.07 to the 0. 0.93 to the 10th. It all should make sense. 0 successes. 10 failures. 10 choose 0 simply tells you how many different ways it can happen. And then we got our answer, 48.40%. Let's pick 6. Let's do 6. Back to our calculator. 10 choose 6. That simply tells me how many different ways you could have 6 successes out of 10 trials. So we have 210 different ways times 0.07 to the 6th, 6 successes, times 0.93, 4 failures, 10 trials, 6 successes, 4 failures, 210 total different ways that you could have 6 check marks, 4 non-check marks. Here's the probability. Oh boy, make sure you know how to read that number. Got to move that decimal 5 times to the left, which will actually produce 4 zeros. 0.0000. Do a quick calculator check. 18. So very unlikely. So once again, I did 10, choose 6. I just let the calculator do it though. Got me 210. 0.07 to the 6th. 0.93 to the 4th. Why would you might ask, why is this so unlikely? Well, think about it, guys. There's only a 7% chance that you have type O negative blood. So if I have 10 people, it should be very, very rare for me to have 6 of them with type O negative blood. There's only a 7% chance that a single person does. The probability of having 6 of them would be very unlikely. But listen, I want to make this all faster for you. I want to make it even easier. I want you to find these probabilities even quicker. We have a command on our calculator that could do this for us. Now, to get to that command, hit second vars. This is your distribution, D-I-S-T-R, it says above vars. Keep scrolling down, way down, boop, 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 till you get to binomial PDF. Binomial, we're working with the binomial distribution. Now, you have to type in a couple things. Trials, 10 trials. P is the probability of success. You got to tell the calculator that. And then X is how many successes you want. So I want 1 success. Now the cool thing is I don't have to do any work. The calculator will literally do all of it for me. It'll do all the math for me. It just gives me the answer, 0.3643. 0.3643. So what did the calculator do for me? It did 10 choose 1. Figure out how many different ways you could have 1 check mark out of 10. 0.07 to the 1st. 0.93 to the 9th. It did all the work for me. 0.3643. I'm done. Then all you got to do is go back to the calculator. Go again, second vars. Go and grab binomial PDF. Whoop, I hit the wrong one. One too many, sorry. Second vars. Binomial PDF. 10 trials. 0.07, success. Now I want 2. So I get 0.1234. That's interesting. 0.1234. What did the calculator do? 10 choose 2. 0.07 squared. 0.93 to the 8th. Easy. Why don't you go ahead right now and practice doing the rest of these on your own? Either use your calculator, do it by hand, whatever. Just make sure you get all the answers. And voila, here are all the probabilities. Now think about this. There's only a 7% chance that any single person has type O negative blood. So the probability that 10 people randomly all have type O negative blood is going to be very, very, very unlikely. In fact, so unlikely that if that did happen, that would be extremely significant and there would have to be an explanation for it because that should not happen. Even the probability that 9, 8, 7, 6, 5, look how low those probabilities are. What's most likely? Think about that. What's most likely? If you have 10 people, the most likely outcome is none of them have type O negative blood. That is what's most likely, 48.4% chance. Because with 7%, you really shouldn't have that many people at all. Now, you could have 1, you could have 2. Those probabilities are a little bit more likely, 36%, about 12%. Even 3 people is somewhat possible at about 2%. But again, anything after that, this is very, very skewed to the right. The most likely outcomes are 0, 1, or 2. That's what's most likely. Anything at that far end is going to be very, very unlikely. But at the end of the day, guys, what I need you to understand this video is how to calculate these probabilities with the function. It's a very, very simple function. Very, very elegant function. You just have to understand what all the pieces are. The first part is new to you. I get that. It's weird looking. But it's just a mathematical formula, a mathematical notation to tell you how many different combinations you could have. And then you have to have your successes P. You got to have your failures 1 minus P. And it's really not that hard. Here's a quick summary to remind you how to utilize Binomial PDF, because this is going to be very helpful on a test or quiz because it does all the work for you, especially multiple choice. So this is just a quick explanation. So if you want to pause and take notes here, second vars is how you get to your distribution list. Select choice A, Binomial PDF, type in the number of trials, type in the probability of success, and then type in how many successes you want. And boom, it gives you the answer. We love it. Now you might be noticing that directly underneath Binomial PDF is Binomial CDF. Let me explain what Binomial CDF does. First, Binomial CDF will find the probability of the number of successes you type and any number below that. So if I choose a Binomial CDF and I type in 10 trials, probability of success is 0.07, and I type in a 3. Now, Binomial PDF, it'll do the probability of exactly 3. But a CDF will do 3 or anything less. So it'll do the probability of 3 or 2 or 1 or 0, and it will add them all together. So a CDF will do the number you type in and anything less. So if I do a CDF with 3, it's going to add together 3, 2, 1, or 0 for you so that you can find the probability of a grouping a little bit easier. But it only finds the probability of the number you type in or less. So please make sure you understand that. If you actually do it, the probability is 0.9964. So again, very, very likely, go back to this. If I add up the first 4 possibilities, 0, 1, 2, and 3, I'm at over 99%. So it's very likely that that's how many you're going to get. 4, 5, 6, 7, 8, 9, 10, extremely unlikely to have that many successes when you could only have 7% chance of O negative blood. So the Binomial PDF, the Binomial CDF are going to save you lots of time on a test or quiz. Let's take a deep breath and let's do one last problem altogether. Skittles reports that 25% of Skittles are red. So the probability of getting a red Skittle, 25%. Not red, 75%. Easy. You're going to look at 5 Skittles and I care about how many are red. Now, every Skittle is either red or not. I like that. Now, since this is a large batch of Skittles, even without replacement, I should assume that there's a 25% chance. Because it's such a large batch, even if I take 5 Skittles out and I eat them, it really should not change the probability of what happens next. Because there's so many Skittles that taking out 5, whether they're red or not red, should not change the probabilities so much that I'm worried, and that's allowed. All right, find the probability that there are 2 red. Let's first show proper notation. You always got to show proper notation. 2 red. All right, 5, choose 2. That's nothing more than a mathematical notation for how many different combinations you could have 2 successes out of 5. I need 0.25 raised to the second. Those are my 2 reds. I need 0.75 raised to the 3. If there are 2 reds, then there must be 3 that are not red out of my 5. Now, the very long way is to do this front part by hand. That's using those explanation points. Wouldn't recommend that. Slightly faster way is to actually go to your calculator and choose 5. Slide over to probability. Select the NCR and then 2. That tells you there's 10 different ways it can happen. Now we have to take those 10 options, times it by 0.25 raised to the 2, times that by 0.75 raised to the 3. Voila, we get our answer, 0.2637. The super fast way to do this is second vars. Go to Binomial CDF, 5 Skittles. Probability of success is 0.25. And I'm looking for the probability of 2 that are successful. Successful meaning red. Hit paste, hit enter again. There's the same answer, 0.2637. You pick your poison. You pick how you want to get the answer. But you must show this notation. All right, what is the probability that there are at most 2 red? The probability at most 2 red means that I'm looking for less than or equal to 2 red. So this would be 5 choose 2 that are red. 0.25 squared times 0.75 to the third. Or 5 choose 1 that's red. 0.25 to the first, 0.75 to the fourth. Or choose 0 that are red. 0.25 to the 0, 0.75 to the fifth. Now, I am going to use CDF to get this answer a lot faster. Second vars. Remember, CDF is built to find the number you type in or less. So 5 Skittles, 0.25 is the probability of getting a red successful Skittle. And I'm going to type in a 2. Because I'm doing a CDF, not only is it going to do 2, it's also going to do 1, it's also going to do 0, and it's going to add them all together for me. So it's going to make my job a lot faster, 0.8965. Do you have to show the setup? Do you have to show the notation? Of course you do. On a free response, yes, you have to. All right, what is the probability of at least 1 that is red? This is x greater than or equal to 1. Now, this would be 5 choose 1 red, 5 choose 2 red, 5 choose 3 red, 5 choose 4 red, 5 choose 5 red. I don't want to waste my time showing all that work, so I'm going to do it one way faster. I'm going to find the probability that there are none red. That is 5 choose 0. That'll find me how many different ways it can happen. I want 0.25 to the 0, no red. 0.75 to the fifth, all not red. Now, this is not what I want, but if I take 1 and I subtract that, I'm left with at least 1. The opposite of at least 1, 1, 2, 3, 4, 5, is none. So if it's much easier to find the probability of none and then do 1 minus that. So I'm going to go to my calculator. I'm going to go ahead and grab a binomial CDF. 5 Skittles. Probability of red is 25%. And I'm looking for none that are red. Probability is 0.2373. Then I'm going to do 1 minus 0.2373. And the probability that at least one is red, that's the opposite of none, is 0.7627. 0.7627. So you got to come up with some creative ways to make the work less for you. Using your calculator will definitely make that happen, but also using some strategy of what do they want, how can I get it, could also make that faster. Guys, honestly, and girls, please do not think that the binomial model is difficult. It's actually really, really simple. It's not that hard to understand. The hardest part, in my opinion, is just knowing that I have a binomial scenario so that I could do all this, because all of this only works if you are binomial. So please make sure you take the time to understand and process what I try to explain to you in this video and why we need this choosing command. Don't let it scare you, because yes, it's this ugly formula with exclamation points, but you do not ever have to use that formula. Use the NCR command on your calculator. Let that get it for you, or even better yet, use the Binomial CDF feature of your calculator to do all the work for you. But you have to know notation. You have to understand what this 5 choose 2 represents. You have to understand what 0.25 squared represents, my 2 successes. You have to understand what 0.75 to the third represents, my 3 failures. And then finding probability with this model is quite simple. All right, make sure you practice.